All right, welcome to notes 5.1 to 3. Despite what it says up here, we are doing 5.1 to 3. And this entire unit, Unit 5, is all about triangles. Now, last unit we talked a bunch about congruent triangles and all the different postulates and theorems that made triangles congruent, and we did a bunch of proofs. There will be a little bit of proving stuff in this unit, but not very much. Mostly we're going to be talking about triangles, their parts, their properties, theorems that go along with that, and then we will be doing a little bit with triangle similarity, which is where the proofs come into play. And vocabulary is going to be absolutely critical in this unit. A huge chunk of the test centers around the vocabulary from this unit, so please pay close attention to the vocabulary and make sure that you have it all down pat. All right, so let's begin with our vocabulary. So we're going to start by talking about the midsegment of a triangle, and the midsegment of a triangle is a segment in a triangle that connects the midpoints of the two sides. So if I were to draw a picture of that, let me get a triangle going here. So here's a triangle, and then if I have a midpoint of this side, and I know it's the midpoint because it cuts it into two congruent parts, and the midpoint of this side, again, cuts it into two congruent parts. If I draw a line in between those two midpoints, that is my midsegment. And then there's a theorem that goes along with it, the midsegment theorem, that says the segment containing the midpoints of two sides of a triangle, also known as the midsegment, is parallel to the third side and half as long as that side. So this line that I just drew here, this midsegment, is going to be parallel to this third side, and also it's going to be half as long. So if this guy's 4, this guy would be 2. Okay, so equidistant. Equidistant simply means that it is the same distance away from both figures. So a point is equidistant from two figures if it is the same distance away from each figure. So back to this triangle that I drew, this midpoint is equidistant from each of these two vertices, and this midpoint is equidistant from each of these two vertices. All right, and then finally, let's talk about concurrent lines. Concurrent lines, or 3 or more lines that intersect at a single point. So let's draw a picture of that. If I had something like this, and something like this, and then something like that, these 3 lines would be concurrent because they all intersect right here at this point. And sure enough, you can see that same figure right here. P is the point of concurrency. So when I have 3 or more lines that intersect at a point, that point is known as the point of concurrency. Okay, let's talk about the median of a triangle. Median of a triangle is a segment that goes from a vertex to the midpoint of the opposite side. We're going to learn about a bunch of segments of triangles, and it's really important that you know where they go from and where they go to. So this is a good way of kind of connecting them in your head, from and to. So this one's from the vertex. So here's my vertex. So it comes from here and it goes to the midpoint of the opposite side. I know it's the midpoint because it's marked as cutting it into two congruent parts. So this one right here, this would be my median. So the next segment of a triangle we're going to talk about is the altitude. And an altitude is the perpendicular segment. It goes from the vertex to the line containing the opposite side. Okay, so the interesting thing about an altitude is it can be inside, on, or outside the triangle because it goes from the vertex. So here's my vertex, and then is perpendicular to the line containing the opposite side. So this is an example, and you'll notice in this case, this is my triangle right here. This yellow is my triangle. I had to extend the side of my triangle in order to be able to draw the perpendicular. So this is an example of where my altitude is outside the triangle. And then again, the yellow is my triangle, and this time it comes from the vertex perpendicular to opposite side. So this time my median is inside, I'm sorry, my altitude is inside the triangle. And then in this last case, I have a right triangle going on. So in this case, for at least 2 of the sides, the median is a side. So in this case, it is again, altitude. Sorry about that. I keep saying that wrong. The altitude is on the triangle. So outside, inside, or on the triangle, and that is the altitude, which is always perpendicular to the opposite side and comes from a vertex. And now we have a theorem. It is the perpendicular bisector theorem, and it simply states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So here I know I have the perpendicular bisector because it shows me perpendicular and it shows me bisecting, which means that it is equidistant from the endpoints. So you can see here that point M is on this perpendicular bisector and is equidistant from A and B. And then, in fact, if I were to draw, a line from A to X and from B to X, then those two would also be congruent, right? Because X would be equidistant from A to B, and every point on here is equidistant. Every point on here is equidistant from both A and B, which means that the perpendicular bisector, what it's considered in regards to point A and point B, would be the altitude because of that triangle that was formed. So then this theorem also has a converse, which states if the point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector. So point X here, if this is true, if AX is congruent to BX, if this is true, then X must be on the perpendicular bisector. So it means that this has to be true. These two segments are congruent, and also that this is perpendicular. All right, we're going to skip this section of your notes right now, and we're going to do it in class tomorrow. So don't answer these questions, don't do this construction, don't answer these questions, and we're going to pick up by talking about the angle bisector theorem. And so the angle bisector theorem states if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So if I'm given that E is on the bisector of the angle, and I would know that because I would be shown it in some way. So I would see something like this, right? So this is my angle bisector, shows it cuts into two congruent pieces. Then it must be true that it is equidistant from the sides of the angle. And remember, when we do distance, the shortest distance between 2 points is going to be the perpendicular distance. So these are perpendicular, which is kind of nice because it means I have 2 right triangles going on here, which helps me. And also that these distances are congruent. And then again, this one has a converse, which simply states if a point is equidistant from the sides, then it must be on the angle bisector. So if I see this, if this is true, and I would usually see this also, I would usually see that these guys are perpendicular, then these two distances are the same, then BX here must be an angle bisector. This is not necessarily something you would use in a proof. It's more like we would give you the fact that this had an expression and this had an expression, and you would then know to set them equal to each other because you would know that these guys were congruent because these two are congruent, something like that. Okay, well, this concludes notes 5.13. Again, those several pages that we skipped over, we are going to be doing those constructions in class. So come prepared to do that, and please be sure to do the notes check. Thanks.